Hello, Ben. What are you wanting to tell people?
I'm a big brother.
You're a big brother? Wow.
It's time for Maths with Mr. Thomas.
If we make me happy.
Here we go with Chapter 5, Lesson number 2. This is the second lesson for Standard Deviation. Woo! So, in the first lesson we were looking at the basics. What is standard deviation and how do we find it? Where are you? And this lesson is looking at those Part B questions that pop up in the exam. It is using the standard deviation to compare two data sets. Yeah. So, a quick reminder, what is the standard deviation? What does it show us? Excuse me, I've got this. It shows us the variation. It does indeed, yes. Standard deviation is a measure of the spread of the data, and it's different from the range or the interquartile range or the semi-interquartile range because they're just based on two values. The standard deviation takes into account all of the data, so it's a more accurate measure of the spread or the variation in a set of results. Remember, in the exam on the formula sheet, you are given two formulas. You're given this one, and you're given this one, They look complicated, but they're not really. If you looked at that first lesson, you'll find it's actually quite simple. I do not use the one on the right. I don't teach that one. If you want to know that one, just have a look elsewhere and someone will go through that with you. I prefer the one on the left. I think that's a better formula and it gives a better idea of the standard deviation because it looks at how far the data is away from the mean, which is what the standard deviation is all about. Remember, you will end up with a number, and what that number shows you is the spread. If the number is quite low, if you get a low number for the standard deviation, it means that the values in your data set are close to the mean. So you may end up with something like this. If you had a number line, all these numbers are fairly close to the mean. But if you end up with a high standard deviation, then it means the values are more spread out from the mean. There is more variation in those results. Let's look at some examples then. Examples 1, 2, 3 and 4 are in the first lesson, so I'm picking up with example 5. Here we go. Two groups of people have their heights measured. Yeah! Group 1 has a standard deviation of 2.7 and Group 2 has a standard deviation of 5.9. Part A, write a sentence comparing the heights of the groups. And Part B, which group has the taller people? So, for Part A, write a sentence comparing the heights of the groups. Well, we know that this question is talking about the standard deviation. We've got the standard deviation of 2.7 for Group 1 and 5.9 is the standard deviation for Group 2. Once again, what does the standard deviation show us? It's a measure of the spread or variation. It is indeed, yes. So what this is showing us is because we've got a higher number for Group 2, it means there's more variation in the heights of Group 2. Or if we went the other way, we could say there's a lower standard deviation for Group 1, which means there's less variation in the heights of Group 1. Either way, you want to say what it shows you and link it back to the question. Don't just say Group 2 is bigger, Group 2 is more. Don't say something like that. Make sure you link it back to the question. Here it's talking about the heights of the people, so you would say something like the standard deviation shows that there's less variation in the heights of Group 1. And how do we know that? Well, it's because there's a lower number. The 2.7 is less than 5.9. That's how we know that there is less variation. And as I said, link it back to the question. It's talking about heights, so bring that in as well. Woo! Part B, which group has the taller people? Is it Group 2? No, I think it's Group 1. Well, you're both wrong. This is a trick question. Bum, 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 bum. Why is it a trick question? Exactly. The standard deviation is just a measure of how spread out the results are. It tells us nothing about the heights. You would never get that in the exam. This is a trick question. This is just me testing you to see if you understand what is meant by the standard deviation. And as I said, standard deviation is just a measure of the spread or variation. It doesn't mean that because 5.9 is bigger here, it means the people are taller. Not at all. It just means there's more variation in the heights. Let me demonstrate that with a picture. Let's say we've got group 1 and it looks something like this. And group 2 looks something like this if you lined everybody up. Well, we can see that for group 1, most people are a very similar height. We've got this person who's a lot taller at the end, and this person here who's a lot shorter as well. But you can see most people are a very similar height. There's not that much variation overall in this group. So because there's not much variation, it means there will be a lower standard deviation. This group here, though, for group 2, you can see the heights of the people. They're a lot more varied, and because there is a lot more variation, there is going to be a bigger number for the standard deviation. You could have it, though, where everybody in this group is shorter than group 1. But it's still quite a variation in the height, so there will still be a bigger standard deviation. You could also have it where they're taller than group 1, and again, still quite varied, so still a bigger number for the standard deviation. So the standard deviation shows us absolutely nothing about the heights, just how varied the results are. Let's try another one. Example 6. Ellie looks at her last 5 maths test scores. She has a mean of 88 and a standard deviation of 4.9. Brogan looks at his results. He has a mean of 71 and a standard deviation of 6. Write 2 comments comparing Ellie and Brogan's test scores. So, before I begin this, normally I would pick out all the information. So we've got Ellie and we've got Brogan. Ellie's results, you can see she has a mean of 88 and a standard deviation of 4.9. With Brogan, it tells us there is a mean of 71 and a standard deviation of 6. So, we're looking for 2 comments to compare their test scores. You get this a lot in the exam. It asks you for 2 different comments. So really what it's asking you for is 1 comment for what the mean shows you and 1 comment for what the standard deviation shows. So, if you remember the mean, what is the mean a measure of? It shows us the average! Perfect. If you think back to when you learned about the mean, the median and the mode, they're all types of average. So I would always start that sentence by saying the mean shows that on average. And if you look at the averages, so if you look at the mean for them both, well really that is their average test score. So what does it show you? Well, Ellie has an average of 88, Brogan has an average of 71. So you can say that on average, Ellie has the higher test scores. And you know that because 88 is bigger than the 71. Again, you can flip that. You can always say the mean shows on average. Brogan has lower test scores because 71 is less than 88. It doesn't matter which way around you have it, but I would always say the mean shows that on average. The mean is a measure of the average. Looking at the standard deviation though, what does the standard deviation show you? Well, it shows you for Ellie it's 4.9 and the standard deviation for Brogan is 6. Don't just say Ellie has a lower standard deviation. You wouldn't get the mark. You need to say what the standard deviation shows you. And the standard deviation is a measure of variation. It is. The standard deviation is a measure of the variation. So, because Ellie has a lower standard deviation, it means that there is less variation in her test scores. Whereas Brogan has a higher standard deviation, so you can say for him that there is more variation in his test results. He may have had a large score, then he may have had a small score, whereas Ellie's smaller standard deviation, so they are all closer together, they are closer to the mean. So the sentence there, standard deviation shows that there's less variation in Ellie's test scores, would be perfectly fine. That would get you the mark. It just means that her results are more consistent. And again, you know that because 4.9 is less than the 6. Yeah. Let's try another one. Example 7. The mean running time of the Indiana Jones movies is 120 minutes. The standard deviation is 6.3 minutes. The mean running time of the Star Wars movies is 137 minutes. The standard deviation is 8 minutes. Write 2 comments comparing the running times. So, Once again, pick out the information that you have. For Indy, we have a mean of 120 minutes and a standard deviation of 6.3 minutes. For Star Wars, we can see the mean is 137 minutes and the standard deviation is 8 minutes. So what does that show us? Well, we're looking for 2 comments, and once again, because it's 2 comments, we're looking for a comment on the mean and one for the standard deviation. So, start off by saying the mean shows, and again, link this back to the question and also state what the mean is showing you. What is the mean a measure of? The mean is a type of average! Well done, the mean is a type of average. Well done, Indy. So you can say that the mean shows that on average, and if we look at the average running times for the movies, we can see the average for the Indiana Jones movies is 120. The average for Star Wars is 137 minutes, which means that on average, a Star Wars movie has a longer running time than an Indiana Jones movie, because the 137 is bigger than the 120. And once again, you can reverse that if you like. You can say the mean shows that on average, an Indiana Jones movie has a shorter running time than a Star Wars movie, because 120 is less than 137. Doesn't matter which way around you get it, but just make sure that you say the mean state of what it is you're actually going to be looking at. So you're showing that the mean, make sure you get an average as well. The mean's a type of average, and then link it back to the question. This is talking about Indiana Jones movies and Star Wars movies, so link it to that. And once again, how do you know that? It's because it's these 2 numbers that you are looking at. These are the numbers that you are comparing. For the standard deviation, well, what does the standard deviation show? What is it a measure of? The standard deviation is a measure of variation. It is indeed. Well done, Jack. So you can say the standard deviation shows that there is. And if we go for the Indiana Jones, we could say, well, that's 6.3, that is 8. So we can say that there is less variation in the length of the Indiana Jones movies, because the 6.3 is less than the 8. And equally, once again, you can reverse that. The standard deviation shows that there is more variation in the length of the Star Wars movies, because 8 is bigger than 6.3. But again, say what it is that you're looking at. We're looking at the standard deviation. It's also a measure of the variation. And again, link it back to the question. It's talking about the Star Wars and Indiana Jones movies. Yeah. Example 8. Mary Lou checks the price of a pint of milk in 6 local newsagents. The cost in pence are 54 pence, 49 pence, 46 pence, 57 pence, 52 pence, and 48 pence. Woo. Calculate the mean and standard deviation. Glug, glug, glug. Part B, Ryan checked the price in supermarkets. He found the mean to be 48 pence and the standard deviation to be 2.2 pence. Make 2 comparisons between the 2 sets of prices. So we've got these 2 people. Mary Lou is checking out the price in the newsagents and Ryan is checking the price in supermarkets. So the first thing that we need to do, part A, calculate the mean and standard deviation for the local newsagents. So the mean, remember when it comes to the standard deviation, what do we represent the mean by? X bar! Well done, we call it X bar. Well done, Ryan. So for X bar, that is the mean, and it's the total divided by how many numbers you have. So if you add up the 54, 49, 46, 57, 52, and 48, you end up with 306. Divide that by these 6 numbers, and it gives you an average price, or a mean price, of 51 pence. Woo! We now need to work out the standard deviation. And remember, for the standard deviation, you have to come up with this table. So we've got X. X just represents all these numbers here. So the 54, the 49, the 46, and so on. We've got X minus X bar. And we've got X minus X bar in brackets squared. So we're filling out this table. We've got X, which is 54, but we're taking away X bar. Remember, X bar is the mean, so we're taking away 51. So that is 54 take away the 51, giving us 3. You don't have to write the 54 take away 51. That's just me showing you where it comes from. You could just write 3 in that column. You want to do then 49 take away the 51, which gives you -2. 46 take away the 51. For each of these numbers, you're going to be taking away the mean of 51. And if you do that, you will end up with these numbers here: 3, -2, -5, 6, 1, and -3. Stop! How do you know you're getting this right so far? What could you do? I know! You could add that column up and see if you get 0. Yes, perfect. You are meant to be getting 0. Well done, Erin. Erin, if you've got 3, add 6, add 1, what does that give you? 10. Good. If you then take away 2, 8. And then take away 5, 3. And then take away 3, 0. Well done. So you would end up with a total of 0. Remember, this column should always be 0, unless your mean is a rounded answer. Then it'll be out ever so slightly, so that'll be out ever so slightly from 0. But most of the time, it will end up at 0. We've got x minus x bar, which was this column here. Now what we want to do is square each of these numbers. So 3 squared is 9. -2 squared, well, a negative times a negative is a positive, and 2 times 2 is 4. Remember, in this column, every single one of the numbers will be positive, whether or not this number here is positive or negative, because when you square a number, you always end up with a positive. 6 squared gives you 36, the 1 squared, and then the -3 squared. If you add them all up and again get a total, so 9 add 4 add 25 add 36 add 1 add 9, that gives you 84. Now we have completed this lovely table, we then want to look at the formula sheet. And you can see in the formula sheet, this is the equation that I like to use. It looks as confusing as something that's confusing, but the whole of this top line is just the total of the x minus x bar squareds. And the total of the x minus x bar squareds is 84. Remember that big funky E is the Greek letter sigma, and it's used to represent the total. It means the sum of the x minus x bar squareds. So the total, or the sum of them, was 84. So the whole of that top line becomes 84. We're going to divide that by n minus 1. What is n? How many numbers we had? Good. How many numbers did we have? 1, 2, 3, 4, 5, 6. Good. We had 6. Take one away. 1, 2, 3, 4, 5. Good. So we do the 84 divided by 5. And make sure we put the square root round the whole thing. What quite a lot of people do is they just put the square root of and then write 84 over 5. That's wrong. Make sure your square root is over the whole fraction. So it's the square root of the 84 divided by 5. If you work out 84 divided by 5, you can do that first if you want. You end up with 16.8 and then take the square root of that. Or you could just jump to your answer. Either way, you end up with 4.10 pence for the standard deviation. Part B, Ryan checked the price in supermarkets. He found the mean to be 48 pence and the standard deviation to be 2.2 pence. Make two comparisons between the two sets of prices. So once again, what I would do is just sum up everything that you have so far. So in the newsagents, which is where Mary Lou was looking, there was a mean of 51 pence. We found that just in part A, and a standard deviation of 4.1, or 4.10 is what we found, but right in 4.1. It tells us in part B that Ryan checked the supermarkets, and in the supermarkets there was a mean of 48 pence and a standard deviation of 2.2 pence. And because we're looking for two comments, or two comparisons, we're wanting to write one of them about the mean and one of them for the standard deviation. So let's start with the mean. So I would always write down the mean shows. Show it as the mean that you are looking at here. So looking at the mean, once again, you always want to think, well, what is the mean a type of? And the mean is a type of, say it with me, average. I didn't hear you. Let's try that one more time. The mean is a type of average. Well done. Good. Heard everybody there. So the mean is a type of average. So the mean, or the average price, well, you can see it is cheaper in the supermarkets. So you can say the mean shows that on average, a pint of milk is cheaper in the supermarkets. Or, going the other way around, you could say that on average, that it is more expensive in the newsagents. Again, always start with the mean shows and then make sure that you mention that the mean is a type of average. Link it back to the question. It's talking about the price of milk in supermarkets and newsagents, so make sure you put that in. And we know that for this sentence, I'm writing a pint of milk is cheaper in the supermarkets, is because that 48 is less than the 51. It is those two numbers that we are using. That is our sentence for the mean. For the standard deviation, well, looking at the standard deviation, we've got a standard deviation of 4.1 pence for the newsagents and 2.2 pence for the supermarkets. What does that show you? Well, again, say what the standard deviation shows. The standard deviation is a measure of variation or spread. Good. So make sure you put in the word variation or spread. So we can see that for this, because the 2.2 is less than the 4.1, it means there is less variation in the price of a pint of milk in the supermarkets. And we know that because the 2.2 is less than the 4.1. And once again, you can flip that if you like. You can say the standard deviation shows there's more variation in the price of a pint of milk in the newsagents because 4.1 is bigger than the 2.2. It doesn't matter which way around you have it, as long as you state that you are looking at the standard deviation. Make sure you put in the word spread or variation or varied. Make sure you get that in and then say if it's higher or lower and link it to the question. Again, it's the price of a pint of milk in these places. And back it up saying, look, it's these two numbers I'm looking at for the variation. Woo! And that'll be your 2 marks. Thank you, Mary Lou. Thank you, Ryan. Go and have a milkshake. Example 9. 9? I know. Another example. Matchman dun, 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 claims that there are 60 matches in each of their matchboxes. A sample of boxes each had this many matches. So somebody opened up a box and started counting them and found that there were 61 matches in one box. Another box had 57 matches. Another box had 60 matches. Another box had 61 matches. And another box had 58 matches. Calculate the mean and standard deviation. And then part B, Bernie, make the same claim and have a mean of 60.2 matches per box and a standard deviation of 4. Which company has less variation in the number of matches in each box? Let's start off with part A. Well, you can see that is the number of matches in 5 of the boxes. We have to work out the mean and standard deviation. So let's do it. So for the mean, Miss Moneypenny, how do you work out the mean? That's right, the mean is denoted by x bar. And for x bar, well, the mean is the total divided by how many numbers you have. The total, if we add all of these together, well, 61 add 57 add 60, add 61 add 58 gives us 297. We're dividing that by 5, giving us 59.4. Well done, thank you, Mr. Bond. And that is the mean, even though I got carried away. This is 59.4. We have to now work out the standard deviation, and for that, this is the equation I like to use, and for that, you need this awesome table, where you have x, which is each of these numbers, the 61, 57, 60, 61, and 58. You need the x minus x bar, which is x, the number here, take away the mean, and whatever number that is, squared, the x minus x bar squared. So, for each number here, the 61, the 57, the 60, 61 and 58, we're taking away the mean, we're taking away the 59.4. So, 61 take away 59.4 gives us 1.6. If we do 57 take away the mean, we end up with negative 2.4. 60 take away the mean, 59.4 gives us 0.6. 61 take away the mean, and 58 take away the mean. Stop! What is wrong, Samantha?
Remember, you have to add them up to see if you get it right so far.
You're perfectly right, Samantha. You do. What should you get?
You should get a total of 0.
You should get a total of 0. Let's do that then. Once again, I would always just start with the positive numbers. 1.6 add 0.6 add 1.6, add them, and then take away 1.4 and take away 2.4, and you end up with...
Well, you do actually. You get 0 for this one.
Perfect. Remember, you should always be getting 0 for your total, unless your mean is a rounded number. If it is, it's out slightly, so this will be out slightly as well. We also have x minus x bar squared, which means we're taking this x minus x bar number and we're squaring it. So the 1.6 squared is 1.6 times 1.6, which is 2.56. We're taking negative 2.4 and we're squaring that. If you square a negative, it becomes positive, so that will give us a 5.76. Square each of these numbers, and remember that when you do that, every single number here, because you're squaring the number in this column, will always be positive. Whenever you square a number, it will always give you a positive answer. If you get a total for this column as well, the 2.56, add the 5.76, add the 0.36, add the 2.56, add the 1.96, it gives us 13.2. Woo-hoo-hoo! We now have that total, and remember, for our formula, even though it looks confusing as anything, the whole of that top line is just the total of the x minus x bar squared. That is what that means, the sum of x minus x bar squared. And the total for that was 13.2. So our top line is just 13.2. And we're dividing that by n minus 1. N is how many numbers we have. How many numbers do we have? 1, 2, 3, 4, 5. Take 1 away and it's 4, so it's the 13.2 divided by 4. From that, if we work that out, you could do 13.2 divided by 4, and then that'll give you 3.3, and then we square root it to give us 1.82. That is your standard deviation for the matches in the box for Matchman. Dun dun dun! Part B, Bernie, make the same claim and have a mean of 60.2 matches per box and a standard deviation of 4. Which company has less variation in the number of matches in each box? So far our information that we have gathered, Matchman, we saw there was a mean of 59.4 and a standard deviation of 1.82. That is what we worked out in Part A. For Bernie, there is a mean of 60.2 and a standard deviation of 4. We are not asked this time for 2 comments. We do not have to say the mean shows, and we do not have to say the standard deviation shows. We're not looking for 2 different comments. What we're asked for is which company has less variation in the number of matches in each box. So we need to think from this, is it the mean or is it the standard deviation? Which shows you the variation? Help us out! James, what is it? It's the standard deviation. It is indeed, yes, the standard deviation is a measure of the variation. So for this, we can say that the standard deviation shows, and we are now looking at the standard deviation. And what does it show us? Oh, that was the worst loop in the world. Let's try that again. The standard deviation without chopping up that 1.82. Well, we can see the standard deviation is 1.82 for Matchman, and it's 4 for Bernie. The question says which company has less variation. So the answer is Matchman! Dun, 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 dun! And how do we know? Brilliant. It's because that is a lower number. If it's a lower number, the results are closer to the mean, so there's less variation in those results. So we can say in our sentence, the standard deviation shows. Make sure when you do this in the exam, you would say the standard deviation shows to show that it's standard deviation that you are looking at. So the standard deviation shows there is less variation in the number of matches per box with Matchman. And that would be the answer to your question. Back that up by saying, look, it's these 2 numbers I'm looking at. It's the 1.82 and it's the 4. I'm ignoring the 59 and the 60. It's nothing to do with them. It's just the standard deviation. And as I said, there's less variation because this is a smaller standard deviation. Woo! On a side note, if it did tell you, look, write 2 comments comparing these results. What you would also do is you would have to say something about the mean. And if you were asked for it, again, you're not here, you wouldn't have to do this. But what does the mean show you? The mean shows you the average. The mean does show you the average, yes. You'd say that the mean shows on average. And if you look at these 2 numbers, we can see it's higher for Bernie. So you can say the mean shows there are more matches per box with Bernie, because the 60.2 is bigger than that 59.4. Or if you flip it, the mean shows that on average there's less matches per box with Matchman because the 59 is less than the 60. But as I said, you're not asked for that. It's nothing to do with the mean. It's nothing to do with the average. You do not need that. That's just in case you wanted a bit more practice. Woo! Don't play with matches. Try some of these questions. Lesson 5.5, Standard Deviation 2, Comparisons. There are some questions in the Lecky and Lecky National 5 book. There's also some in all the other National 5 textbooks. And if you look at some of the past papers, you will see that the past paper questions are very similar to all these examples that I have just done. And by the time you watch this video, there's probably quite a lot of them. So have a look, try some of them as well. Best of luck! Have fun! See you again! Hopefully! Bye!
Every week me happy.